Kjeldahl's method is another method, student, by which we can find out the percentage of nitrogen, or we can estimate nitrogen quantitatively from the given mass of the organic compound. So for Kjeldahl's experiment, this setup is required. If you will see, this is the round bottom flask. You can say it's a Kjeldahl flask which is consisting of longer neck, and there is a rubber cork that is consisting of an opening. Into that I have inserted a glass pipe which is connected to a bulb. So this is a collector. You can say it collects the gaseous product which comes from the Kjeldahl's flask. And another end of this flask is taken into a flask, conical flask, which is consisting of standard solution of acid. So the very first thing what we take into this flask, if you will see this part, I have taken known mass of organic compound which contains what? Nitrogen. So this known mass of organic compound, if you will see, let's say the mass of the organic compound is what? Small n. The very first thing, this known mass of the organic compound is mixed with the concentrated H2SO4. So when you add concentrated H2SO4 to this organic compound which contains nitrogen, it gets converted to a soluble salt of ammonium sulfate. So you can say organic compound is first converted to what? Ammonium sulfate. Now to this we add sodium hydroxide. So when you add sodium hydroxide, it decomposes ammonium sulfate which is formed, and it releases ammonia gas. So all the ammonia gas which is evolved from this flask after the reaction is allowed to collect into this Kjeldahl strand. Now the amount of ammonia which is formed is unknown for us. By knowing the amount of ammonia which is formed, we can find out the percentage of nitrogen. So this ammonia gas is allowed to pass through, and it is allowed to react with the known volume of the concentrated sulfuric acid. Student, you can take any of the acid. Right now I have taken what? Sulfuric acid. So this sulfuric acid being acid and ammonia gas is being base, there will be neutralization reaction. So we have to check that some part of the sulfuric acid will react with the ammonia and some part will be what? Unreacted. So by knowing the amount of unreacted sulfuric acid, we can find out the amount of ammonia which is reacted, and from that we can find out that how much ammonia is formed, and from there we can find out the percentage of nitrogen. Basically, if you will revise this step, then what we do, we take organic compound, and this organic compound is mixed with the concentrated sulfuric acid. Can you see this? So this organic compound decomposes and it forms water soluble salt ammonium sulfate. To this ammonium sulfate we add sodium hydroxide. This sodium hydroxide dissolves ammonium sulfate and it releases ammonia gas. Now this ammonia gas is allowed to react with the known volume of excess volume of sulfuric acid, and from there the amount of acid which is reacted and non-reacted is determined, and that non-reacted sulfuric acid is again allowed to titrate with what? Sodium hydroxide. That is the third part of the experiment. So after doing this, student, we can say the amount of ammonia liberated is determined by estimating the amount of sulfuric acid consumed in the reaction. Now how it is done? It is done by estimating unreacted sulfuric acid left after the absorption of ammonia by titrating it with the standard solution of sodium hydroxide. Means the mixture, if you will see, since we are passing ammonia gas into the mixture, student, so the ammonia gas will react with some quantity of the sulfuric acid and some quantity of the sulfuric acid will not react. So unreacted sulfuric acid is again allowed to titrate with the standard solution of sodium hydroxide. The difference between the initial amount of acid taken and that left after the reaction gives the amount of acid reacted with the ammonia. If you'll see this, what we do, let's say the volume of sulfuric acid of molarity capital M. If you'll see, I have taken some amount of sulfuric acid and its molarity N, and the V ml is the volume of the sulfuric acid, and the volume of NaOH of molarity M which is required for the titration is V1 ml. Means when we are titrating sodium hydroxide with sulfuric acid, student, then if you'll see, the sulfuric acid produces 2H plus ion and the sodium hydroxide produces 1OH minus ion. So can I say V1 ml of NaOH of molarity will require half of its volume. So V1 ml of NaOH of molarity M, it requires V1 by 2 ml of H2SO4 of molarity M unused. Unused means this is the acid which is unreacted. So volume of H2SO4 of molarity M is used is total volume minus volume of H2SO4 which is unreacted or unused. So total volume which we have taken is what V, and this is the unused volume V1 by 2. So V minus V1 by 2 you can say. So V minus V1 by 2 ml of sulfuric acid of molarity M is consuming double amount of ammonia. So it will be 2 into V minus V1 by 2 ml of ammonia. Why we are multiplying 2, student? Because 1 mole of sulfuric acid can consume 2 mole of ammonia. So if I am taking 1000 ml of 1 molar ammonia, then 1000 ml of 1 molar ammonia will contain 14 gram of ammonia. Sorry, 14 gram of nitrogen, because there is one nitrogen and the atomic mass of nitrogen is 14. So from here if you will see 2 and V minus V1 by 2 ml of ammonia solution of molarity M will contain 14 into capital M into 2 into V minus V1 by 2. This is the expression which indicates the amount of ammonia formed, and that is divided by what, 1000. So 14 I have taken because the atomic mass of nitrogen is 14. M is the molarity of the acid and this is the amount of ammonia formed, and that is divided by about 1000. So let the mass of organic compound that we have taken in the Kjeldahl flask is what, m gram. So for m gram of compound, how much gram of the nitrogen, student? Now we know that the nitrogen which is present in ammonia is 1 atom, so it's 14 gram multiplied with the molarity of the acid, and this is the amount of ammonia formed. So V is the total volume of the acid, V1 by 2 is the volume of NaOH, you can say consume, or you can say it is the volume of acid which is unused, and it is molarities we are dividing by what, 1000. So for 100 gram, how much it will be? You have to just multiply this part with the 100, then you'll get what percentage of this. So it will just simplify, then what would happen, this will get cancelled and this will become, the formula will be 1.4 into molarity of acid into volume of ammonia formed, that is V1 by 2, and that is mass of the organic compound. So by using this formula we can calculate amount of nitrogen from the given organic compound by Kjeldahl's method.